everyone, welcome to Digital Electronics Lab. Today experiment name is 3-bit asynchronous counter. Why it is called 3-bit? That is, if the input is n, then output will be 2 to the power n. So if the n equals to 3, then output will be 2 to the power 3, that means 8. We can see the 8 combination in the asynchronous counter. So first of all, we draw the circuit diagram. These 3 JK this JA, KA, QA, QA bar, next JB, KB, QB, QB bar, JC, KC, QC, QC bar. So there is a clock connection. Output is going to the next clock pulse. Same. JA and KA is shorted. JB and KB also shorted. JC and KC also shorted. This shorted point going to connection, that is high, that means plus. VCC we connect in the 6 pin number. Okay, this is clock pulse. There are another connection that is called CLR bar. It is going from the input. Now in our lab there are 7473 IC, that is dual JK flip flop. Now we draw the pin diagram. One, two, three, 4, 5, 6, 7. At pin number 1, it is CLK1. Pin number 2, CAR1. Pin number 3 for K1. Pin number 4 for VCC. Pin number 5 for CLK2. Pin number 6 for CLR2. And pin number 7 for J2. Next, going to another part, 8, pin number 8 for Q2 bar, pin number 9 for Q2, pin number 10 for K2, pin number 11 is for ground, pin number 12 it is for Q1, pin number 13 Q1 bar, pin number 14 J1. So this is 7473 IC. It is called dual JK flip-flop. So in this IC there are two JK flip-flop. As we can see that we require 3 JK flip-flop, so we need another IC. So first from this IC we can give the pin number. You can see J, that means J1, it is going to pin number 14. Next K, it is 3. Sorry. Next QA, this one, that is 12. Next JB, that is J2, 7. KB, that is 10. QB, that is 9. This next IC, so we have to give the pin number in dash. 14 dash, 3 dash, you can see, and 12 dash. Now we go for the CLR bar. So first is 2, next 6, another IC, that is 2 dash. So we represent dashed for the next IC, second IC. Next go into the clock. You can see the clock is going to pin number 1. Next clock go to pin number 5. It is second IC, 1 dash. So it is the circuit diagram. So we can see the circuit diagram that is plus VCC. So we have to connect from pin number 4. If we consider this is pin number 4, so 4 is going to pin number 14 of first IC. Pin number 14 and 3 are being shorted. Next, pin number 3 and 7 are shorted. You can see the line. Pin number 7 and 10 are being shorted. Next, pin number 10 and pin number 14 dash, that is second IC, shorted. Pin number 14 and pin number 3 of second IC are being shorted. Next, going to clock from the kit, that may be 1 Hz. If we give the high frequency, then you can't see the combination. So clock is going to pin number 1. Next, pin number 12 and 5 shorted. Pin number 9 and 1 dash. 1 dash means that is second IC shorted. These 3 are the output. It is QC, it is QB, and it is QA. It is LSB, this segment bit, it is MSB, most sequence bit. So we now go to the truth table. What is the truth table? As we talked earlier, that we get the 8 combination. That is 0, 1, 2, 3, 4, 5, 6, 7. For 0, 0, there are 3 output, you can see QC, QB, QA. So for 0, 0 it is 0, 0, 0. For 0, 0, for 1 it is 0, 0, 1. For 2 it is 0, 1, 0. And for 3 it is 0, 1, 1. For 4 it is 1, 0, 0. For 5 is 1, 0, 1. For 6 is 1, 1, 0. For 7 it is 1, 1, 1. So this is the truth table of this counter. So as it is 3-bit asynchronous counter and it is going to 0 to 7, you can say that it is 3-bit asynchronous up counter. It is 3-bit asynchronous up counter. So what you see at the kit, that 3 LED of this output will be glowing simultaneously. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. If we want to restart from the beginning, then you have to switch off this. It is always one condition, high. If we lower this and then high, then these states will start from the beginning. So it is up counter. If we want to design down counter, we have to connect from QA bar. Then the connection will be here, QA bar, QB bar, and the output we get from this QA bar, QB bar and QC bar. Then it will count from high to low, that will be down counter. That first will be 111, next 110, 101. Now we check this circuit in the kit. Okay, this is 2 IC of 7473. Now we connect the connection. So first of all, we give the power supply, that is plus 5 volt to each IC. We know the 5 volt is going to pin number 4, and we have to short 2 IC. So pin number 4 of both IC are being shorted. Next connection, as you see in the circuit diagram, the 4 of first IC is going to, now we have to give the ground, that is 11, 8, 9, 10, 11, and both the 11 will be shorted. These are first work for every circuit diagram. Ground and VCC will be connected first. Then from pin number 4 of the first IC and pin number 14 same IC will be shorted. Next, pin number 14 and 3 we have to go serially. Pin number 14 and 3 is connected. Keep the rough sheet in front of you to tally the circuit diagram. Next, pin number 3 and 7. Pin number 3 and 7 of same IC will be shorted. Next, pin number 7 and 10 of same IC. Pin number 7 and 10 shorted. Next, pin number 10 of first IC and pin number 14 of second IC shorted. Next, pin number 14 and 3 of second IC shorted. Next connection, pin number. So now the input connection are complete. Next we go to the clock pulse. So clock pulse is connected to pin number 1 of first IC. Next clock pulse, that is pin number 12 and 5 is shorted to pin number 12 and 5 of first IC. Disconnected. Next, Pin number 9 from the first IC, and pin number 1 of the second IC is connected. Okay, now go to the CLR. CLR is from the input. It will go to the pin number 2 of first IC. Next, pin number 2 and 6. Pin number 2 and 6 of first IC has been connected. Next, pin number 6 of first IC, and pin number 2 of second IC will be shorted. Now we go for the output. For first output, that is QA, it is coming from pin number 12 of first IC. Next output from pin number 9, of first IC. Next output from pin number 12 of second IC. So I think all the connection is connected. Now we see the output. Okay, for the high condition of CLR, you can see this is 0 0 0 0 0 1 0 1 0 0 1 1. If you want to start from the beginning, you just off this input and then on it. 0 0 1 0 1 0 0 1 1. Close the camera, you can see it. 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. If you give the clock pulse in 10 Hz, it will be going faster. You can see it. So as much as we give the clock pulse low frequency, you can see it properly. So I give the clock pulse from 1 Hz. Okay, as I talk you that it is the up counter, 3-bit up counter. Now if we want to do the down counter, we just connect from the pin number 13 instead of pin number 12, that is Q1 bar. So I just open from the pin number 12 and connect it to the pin number 13. Connection of 12 is going to pin number 13. And next connection of 9 is going from pin number 8. Second IC, that is from pin number 13 instead of pin number 12. So what we saw at the previous state, that is 0 0 1 0 1 0. Now we see that is from 1 1 1. Starting from 1 1 1, if high, it is been high, that is CLR. You can see this down counter 1 1 1, then 0 0 1 0 1 1. You can see it is 3-bit asynchronous down counter. So we do the both circuits, that is 3-bit asynchronous up counter and down counter from the same circuit. We just connect 12 9 12 dash if we want to do the up counter, and if you want to do the down counter, we have to connect 13 instead of pin number 12. We have to connect a pin number 8 instead of pin number 9, and we have to connect second IC, that is 13 dash instead of pin number 12 dash. I think it is satisfied the truth table. Thank you.